Ladies and gentlemen, thank you for standing by. Welcome to the U.S. Department of Transportation Crack Treatment Overview Project Selection and Design conference call. As a reminder, this call is being recorded. At this time, all participants are in a listen-only mode, and later we will conduct a question-and-answer session. Instructions will be given at that time. If you should require assistance during the call, please press star, then 0. I would like now to turn the conference over to Mr. Jason Dietz. Please go ahead, sir.
Thank you. Welcome, everybody. Hope everybody's doing well. I'd like to welcome you to our PPRA, Pavement Preservation and Recycling Alliance, FHWA Partnership webinar series. And as the name shows, crack treatments is what we're going to discuss today. On the far left-hand side on the chat box, you'll see some of the poll questions. I'm going to stop the poll questions here in a little bit, but if you hadn't had a chance to respond, I ask you to please go in there and choose what we currently have, one person or two, or answer those questions appropriately. I'd appreciate it. In addition, I also want to mention questions. Questions are encouraged. Please enter your questions in the question box, in the chat box, and share those electronically. We'll try to get to them, but in a matter of fashion, we'll probably won't get to them until the end of our presentation material, so bear with us. In addition, in the chat pod already, you'll see that the presentations will be available at the end of a conclusion, as well as some evaluation questions that we'll have for you to answer. Now let me talk a little bit about the reasoning for this webinar. Pavement preservation is a sum of the strategic activities performed to preserve our investment of our roadways. It's important because it enhances the safety, extends our service life, it improves our functional performance, and it increases our user satisfaction, which is very important. Our key principle in pavement preservation is keep the good roads good, and that's really what we're trying to do here. So let me introduce Brandy John. Brandy is a learning and development professional. She holds a CPLP, Certified Professional in Learning Performance, and has focused the last 15 years in her career specializing in education outreach programs, knowledge transfer, and the creation of robust training programs. As a training director for CRAFCO, she is responsible for all content development, management, partnerships with the industry, and implementations. I asked her a little bit about some of her hobbies, and she mentioned that she is from Pittsburgh, Pennsylvania. She's an avid Steelers fan, and she enjoys spending time outdoors with her husband and watching her two sons play baseball. With that said, I'd like to welcome Brandy. Brandy, take it away.
Thank you, Jason. I appreciate the introduction. Hello, everybody. I hope you're all doing well today. And I know Jason's just going to start closing out these polling questions here, and we will continue into the main presentation. There they go. Looks like he's wrapping all of those up. Thank you to everyone who participated and responded to those questions. So as Jason mentioned, we're going to talk about crack treatments. This is a two-part series, and this is a a training that we work very closely with ISSA in conducting a crack seal workshop annually at the Slurry Systems Workshop. So we have broken this down to two different sections. So my counterpart, Brian Darling, is on the call as well today. So this first portion today regarding crack treatments, we're really going to focus on the overview, project selection, design. We'll talk about materials and testing. In a secondary session that we're going to plan out in the future, we'll talk more specifically about the appropriate equipment and application best practices and techniques. So let's take a look at what our agenda is today. We're going to spend time in 5 different sections. First, we're going to talk just high-level overview of crack treatments. Then we'll get into how crack treatments are used as a pre-treatment to other surface treatments, and we'll look at some exciting data coming out of NCAT. Then we'll spend time in the third section looking at crack formation and types and the importance of understanding those and how they relate to the type of sealant that you select for the work that you need to have done. Then we'll move into application best practices. We'll talk about some application techniques, the sealant service life that studies are indicating that come out based on the type of installation that your crews are performing. And then we'll spend time in the last section looking at sealant specs, different testing methods, and the variables that go into selecting a sealant and how those relate to actual field performance. So that's our main topics for today. And before we move into that very first section, this overview section, I want to ask Jason to launch our first polling question. Want to look at gauging the audience here so we just have an understanding of the experience of those of us on the call today. If you can participate, we'd appreciate your responses specific to your organization that you work with or for. Are you currently crack sealing annually? Do you have a full-blown comprehensive crack sealing program? You have crews out every year? Is it something you do a little bit more infrequently? Maybe you're rotating different roads every 3 to 6 years. Or are you at a point where you're not currently crack sealing or just interested in learning more and perhaps looking at best ways to implement a crack sealing program in your area? So we'll just give it a minute here. It looks like responses are still flowing in. Alrighty, thank you everybody. Looks like Jason's going to share those answers with the group now. So a lot of us are out there crack sealing. Good. Thanks for responding, everyone. Appreciate it. So let's go ahead and move into our first topic. First, I want to spend time talking about the differences in crack sealing and crack filling. These terms are often used interchangeably in our industry, and I really want to just talk about what the differences are. But ultimately, what is a crack treatment? We know that they are the most cost-effective pavement preservation methods out there. Basically, dollar for dollar, you get the biggest bang for your buck in comparison for the money invested as it relates to the sealant service life and the pavement life extension that come out of these treatments. And it's always just about protecting our investments and maintaining our infrastructure. So looking at the definition, so what's the difference? The SHWA defines crack sealing as specialized treatment materials that are completely preventing the intrusion of water or debris down into the base and subbase of the pavement. So that's ultimately what we're trying to achieve, is really protect the base and subbase. For crack filling, we're looking at what are defined as ordinary materials, so more of your emulsion, sand and oil type materials. And crack filling is really used on areas where we're just looking to kind of fill the void and reduce the amount of infiltration down into the base and the subbase of the pavement. So there is a difference in those two terms, though we know they're used quite, again, interchangeably within our industry. Again, right here from the FHWA, a quote talking about crack sealing is the single most cost-effective preventative maintenance tool available. I think many of us already know this today. Again, protecting our investments, maintaining our infrastructures, and really limiting future deterioration. It's a big pothole prevention method as well. So some of the other side-by-side comparisons, when we look at crack sealing, again, we're looking at complete prevention, waterproofing, if you will, in comparison to crack filling, where it's more of just a filling the void. Crack sealing, again, specialized materials, and they are highly elastic and flexible. And we're going to look at that more in the testing section when we're talking about specifications and how important that is when you're crack sealing and understanding the movement or the anticipated seasonal and the thermal movement that you might be having in your pavement. Crack fillers are more rigid or semi-rigid materials, so they're not going to be able to accommodate seasonal and thermal changes in your pavement or crack movement. Crack sealing, again, requires a little bit more crack preparation. Routing might be involved. Placement configurations vary greatly with crack sealing. Crack sealing is more of a cold applied materials or emulsions, dusting with sand. One of the biggest things I want to call out on this slide is talking about the service life. when we're talking crack sealing, if we're looking at routing and sealing, and we'll get into this a little bit more and what that means, but if we're routing and sealing, that the average lifespan of just a blow-and-go treatment, we're looking at about 5 years. On a new pavement, if you're routing and sealing, we've seen up to 10 years of sealant service life in independent studies. So we're seeing great performance out in the field. On the crack filling side, we know that fillers aren't appropriate materials for moving or working cracks. They're not able to accommodate movement, but for non-working cracks, they do work for a few months, and then in a lot of chances, 2 to 4 years of service life for crack fillers. So just looking at the differences there, and again, here's a look at some of the differences in the materials. So crack sealants, again, they're specialized materials. So we're talking engineered products, polymer modified type materials, asphalt rubbers. On the filling side, we're looking at, again, emulsions, fiberized asphalt, sand and oil type applications. So let's go ahead and slide into the next section here. We have another polling question. So Jason, I'll ask you to launch this. We're going to talk next about crack treatments in terms of crack sealing before other surface treatments and the impact crack sealing has on the effectiveness of chip seals and slurry seals and microsurfacing. So I want to ask the group here, in your organization or in your territory or in your town, are you currently crack sealing as a pre-treatment to your other surface treatments? Are you not crack sealing first? Or if you do not know or are unsure? And it looks like responses are still rolling in. All right. So it looks like we have a pretty mixed bag there, but it looks like the majority of the group are crack sealing as a pre-treatment. All right. Some people are not, and a good portion do not know. Thanks, Jason. Thank you for sharing that poll. So let's go ahead and move in and talk about some of the great data we're seeing come out of NCAT. So again, crack treatments, as you can see in the photo here, are used in conjunction with other surface treatments. We know that if you go in and seal up the cracks prior to your surface treatment, it's going to help extend the service life and the performance of that other surface treatment. So crack sealing is not only effective as a standalone treatment, it really is effective working in conjunction with other pavement preservation methods that you might be doing on a daily basis. So NCAT, that's the National Center for Asphalt Technology. They're based out of Auburn, Alabama. They have a whole bunch of test tracks and roadways down there that they're doing a lot of great independent studies on. They're testing a whole bunch of different pavement mix designs, preservation treatments. So what we're going to focus on is this green line, if you see here. It's Lee Road 159, and that's what we're going to talk about in this study. But I just wanted to share, this is a print screen directly from their website. It's pavetrack.com. I encourage you to go there and check out their website. All of this data is available on their website. Lots of good research that they provide there to the industry, to the public. But looking at Lee Road 159, this is a county road that goes up to a stone quarry. So it's a 5.5-inch thick paved asphalt road. What they did was they took 2 sections at the beginning of that surface, and they made 2 control sections. They did nothing to it, applied no treatment. And then moving down along that roadway, they broke it out into 23 different sections, and they applied different pavement preservation applications and materials onto each section. And the entire purpose of the study was really to look at quantifying the life extension benefit of each pavement preservation treatment. So we've been really excited about the good data coming out of here. So this slide is just showing you how to read the data. You're going to see on these next few slides, they're all laid out like this graph. This red line indicated on this graph is the control. So all of the blue dots are the data they took from each test section in relation back to the control section. So everything they're looking at is how effective is this pavement preservation treatment in reducing cracking, rutting, etc., in comparison to the section that was our control that we didn't do anything to. So looking at this first slide, L5 was the section that they did a standalone crack seal on. They did some routing and sealing there. And as we can see on the plot graph here with the dots, after the first year, there was still 100% no cracking and in comparison to the control. So control had cracked. There was no cracking in that section that they had put crack sealant in. It was still performing at 100%. By year 2, some of it had opened up in certain areas, but was still performing. There was still 75% less cracking than that control section where they had performed absolutely no treatment. So good information there showing the effectiveness. And here's a picture of that. This bottom half of your screen, let me get my little, my drawing tools out here Jason told me about. So this line here in this road, this shows you the section that splits the different sections, excuse me. So this lower section here is the control section that has no treatment, and you can see how cracked open it is. This looks like it was a wet day. You can see the water infiltrating down into the cracks there and off to the side of the road. And then at this white line, this starts L5, which is this crack sealing section here, and you can see all of the sealants, all the cracks are sealed up. They're performing. It's doing what it's intended to do, preventing the water from infiltrating down into that pavement there. So in the next section, L6, they did a single chip seal. So in this treatment section, they did not crack seal first. They just came out, cleaned, and put down a single layer chip seal. Now, it performed awesome through the first year. You can see all the data points here on the bottom line. It was performing at 100% after that first year and that first season. But in year 2, when we got into that second winter of 2014, you can see that all of the chip seals started cracking open, and in fact began cracking and had more cracking in comparison to the control section. So basically what we were looking at from this data was telling us that after about 2 years it loses any value in comparison to having done nothing. So what we looked at next was the next section where they came in and they did a crack sealing pre-treatment first of all the cracking, and then they came in and put a single layer chip seal down. And you can see here just the outstanding performance here. So across the board after 2 years, 100% performance. So huge swing there. So without crack sealing, it basically lost all benefit after 2 years. And just by crack sealing first and then putting that chip seal down, it was still performing at 100% after 2 years. So great data there, and showing that crack sealing helps the effectiveness of other surface treatments. And here's a picture of these sections. So you can see here the section that has the cracking is open here in the chip seal, and then the white line that goes across the street, and the section beyond it is where they crack sealed and then applied the chip seal. And then we'll see the same thing here, so you'll see duplication. This section was a micro surface. They didn't crack seal first, went down, put down a micro. After 1 year, there was about 50% less cracking in comparison to the control section. After 2 years, only about 15% less cracking. And then in section L12, they crack sealed first as a pre-treatment and then applied the micro. And we saw better performance of the microsurfacing. After year 1, 90% less cracking, and at year 2, 60% less cracking. So again, just showing the performance enhancement by crack sealing as a pre-treatment really helps extend the performance of all of your other surface treatments. The impact of crack sealing that was published by NCAT, they came out and said as a standalone treatment, crack sealing reduced cracking by 75% in comparison to doing nothing. It reduced cracking 100% with a chip seal in comparison to not crack sealing first. And with micros, it reduced cracking by 45% for microsurfacing treatments. So really good data coming out of there. All right, now that we've talked about crack sealing as a pre-treatment to surface treatment, let's move into our next section and talk about cracks, their formation and the different types. So Jason, again, I'll ask you to launch our next polling question here. If you will kind of rate your familiarity with how familiar are you with the different types of cracks and how they are formed. Would you say you're an expert, you're really familiar? intermediate, pretty familiar, or a beginner, a beginner and just learning. All right, looks like the answers are slowing down now. Most people have their responses in. And again, kind of across the board here, most people saying that they are intermediate but pretty familiar, and then we have a pretty split between experts and beginners. So, all right, thank you for sharing, guys. So let's move on and take a look at crack formation and its different types. One thing that we know is that all asphalt is going to crack. When that pavement is first constructed and first laid, it is its most flexible. And we know that over time, oxidation from the sun, the seasonal temperature changes, traffic loading, all of those stresses that pavement has to withstand, it's going to eventually crack. So we know that it's inevitable. It's going to happen. And again, it's getting horizontal movement by thermal movement, right? It's cold in the winter in most places. Your pavements shrink and contract, and then it gets hot in the summertime. Temperatures rise, your pavements swell, and they expand. So that constant thermal movement is always part of why cracks form in your pavement. And then your traffic loading is a big part of that vertical movement that pavements have to withstand, but also is part of the cause of crack formation in your asphalt. So what we do is we define high-moving cracks and low-moving cracks. And the indicator of that is 1/8 of an inch or 3 millimeters. So it doesn't sound like a whole lot, but what we are always looking at is trying to understand is this crack moving? Is it working? Is it opening and closing a lot throughout the season? And the reason why we're trying to understand if a crack is moving or not is because that is important in your sealant selection. If you have a crack that is going to be experiencing thermal movement and opening and closing with those seasonal highs and lows, you have to select the sealant that has the flexibility, the high temperature stability, and the low temperature properties to be able to accommodate all of that movement season to season and resist cracking in the winter and resist tracking in the summer. So that's why we're always looking at trying to understand, is this crack moving or not? And the main takeaway here, again, is that indicator is 1/8 of an inch. If we think a crack's moving more than 1/8 of an inch, we deem that as a high-moving crack. And then on the opposite side, if it's moving less than 1/8 of an inch, we deem that a low-moving crack. So a question I get a lot is, how do I know? Am I going out there with a ruler and measuring it all year? No, we know that's not realistic. People aren't doing that. But a great way to understand that is by the type of crack. You can kind of take an educated guess by looking at the type of crack. Cracks that are going to be low-moving are typically going to be fatigued areas. The more concentrated cracking in an area, the lower anticipated movement. The further spacing between cracks, the more anticipated movement. So low-moving cracks are going to be longitudinal type cracks or fatigued and alligator areas. Cracks also grow. This is something else we know. I get asked a lot, when should I start crack sealing? How wide does a crack have to be before I should start a crack sealing program? And, the answer there is as soon as you have a crack, you have a problem. You're letting water down into the base and the subbase of your pavement. So kind of standard is about 1/8 of an inch. If you have cracks that are open, those are pretty small hairline to 1/8 of an inch. You should begin crack sealing. Because what we know is going to happen is they're going to continue to deteriorate. That traffic loading in those wheels, that abrasion driving over the face of that crack is going to wear it away and open those cracks up, along with any seasonal temperature changes, that thermal movement. It's going to continue to degrade and ravel away and open that crack up. So we do encourage you to crack seal earlier than later. It's, again, about preserving our pavements, keeping our good pavements in good condition. So looking at the types of cracks, this is a transverse crack that's running in this photo here. You can see it runs perpendicular to the driving lane. We always anticipate that these are high-moving cracks. They're formed often in one of two ways. thermal, which we've talked about a lot here already. Or the other way it's formed is if it's an AC overlay over a existing concrete roadway, anywhere there is a joint in that underlying concrete pavement, we're going to anticipate that movement from that underlying joint is going to reflect up through that asphalt overlay, and you're going to get a crack there. These are always moving cracks, and we definitely encourage routing and sealing in examples such as this, and selecting a really good sealant that's going to be able to accommodate that movement that you're going to achieve between seasons. Longitudinal cracking, so these are the cracks that run parallel with your driving lanes. They often are formed also in one of two ways. One is a construction joint when they're laying that HMA mat, right? They lay that one section of paving lane. It cools down when they come back to lay down that second paving lane right up against it, adjacent to it. You get a cold joint there, and that's always the weakest spot in that pavement. And that's why you see those longitudinal cracks that run for miles and miles and miles along with the roadway. We always highly recommend sealing those construction joints up. I'm sure we've all been on the roads and have seen where left untreated, those continue to ravel and degrade and open up into really wide distresses and much more costly, expensive issues if you let them go for years. So definitely encourage crack sealing in both of the images shown on this slide. Definitely great candidates for crack sealing. So we talked about cold joints. The other ways that longitudinal cracking forms is often just by traffic volume, traffic loading. They often occur in the wheel path in the road. And the thing with the longitudinal cracks you find in a wheel path, we definitely also highly recommend crack sealing those as well, because this is the area that often gets rutted right there in the wheel path. Water flows down into it, and this becomes susceptible to becoming an alligator, that rutted alligator area we so often see in our asphalt roadways. So again, both of these longitudinal cracks formed for different reasons. One's a cold joint, one by traffic loading, but definitely highly recommend crack sealing both of these to help preserve those pavements. Block cracking happens as a pavement ages, and there are some photos here of block cracks. So block cracking gets more and more closely spaced together as pavement gets older. So in this bottom picture, you can see the blocks are almost alligator looking. It almost looks like a fatigued area at this point. And I get asked, would you crack seal this? And my answer would be, it depends. So if you're just going to go in and maybe do some of the larger cracks in here, that might be appropriate. But just to go in and crack seal all of those cracks as a standalone treatment, no, we would not recommend that. There's too high of a crack density on this pavement in this bottom photo. Now, the other question is, what's the next thing you're going to be doing to this road? If you're coming in and you're going to do a surface treatment, if you're going to come in and put a chip down, or you're going to do a slurry on top of it, then we absolutely would highly encourage that you crack seal every single crack there, knowing that it won't be a standalone treatment, that a surface treatment will be coming in and being laid on top of that. The photo above the block cracking, this is in a newer pavement, looks like it's in a residential area, actually in an old a slurry that's opened up. So this would definitely be a candidate for crack sealing in this photo. Looking next at edge cracking. So there's kind of two different types of edge cracks here. One is in this gutter, right, the concrete against the asphalt here in this edge cracking. We always are going to encourage that these edge cracks or joints be sealed. We know that roads are designed to shed water off to the gutter, out to the edges. And so if left unsealed, we have this joint where the concrete meets the asphalt, and we know the road is designed to send water right to that joint. We now just have water flowing down into that base and that subbase. It's wearing out the underlying structure of that road. And then what we see in this photo here is how the asphalt has cracked along the edge here. Again, this looks more like a residential area. So you have an unsealed edge joint, and then you have a bunch of residential traffic, garbage trucks, recycling trucks coming in, and the water's under there wearing out that underlying base, and that traffic is going to wear out that pavement there and that where it's weak underneath, and now you have additional edge cracking there. So definitely encourage crack sealing edge cracks to help prevent this type of distress from occurring. Fatigue cracks, so we talked about this a little bit earlier. This is in older pavements where they have not really been preserved and have been let go, and they get to a point where you have a lot of interlocked cracking like this. When asked if I would crack seal something like this again, this is not something in this photo that would really be a candidate for crack sealing. Again, unless you would be coming in crack sealing knowing that you're doing it as a pre-treatment to a different surface treatment. I talked about crack density and the amount of crack spacing in an area, and we tend to use that as a rule of thumb. So when you're trying to calculate crack density, what you're really looking at is over a very specific area of pavement. You're looking at the linear footage of cracks that are present per square foot within a specific pavement area. And what we always mention with routing specifically, if you're going to come in and route a reservoir and you're doing a route and seal application, we use a rule of thumb of 20%. If you have crack density greater than 20%, we are not going to recommend routing. We're going to say there's probably a little bit too extensive cracking to run a router to that asphalt. You might more do damage than good. So in this case, we would just recommend just a blow and go going in, sealing, putting an overband down. In pavements where you have less than 20% crack density, we would, again, as a rule of thumb, highly recommend that as a candidate for a route and seal type application. And again, other variables always come into play, but that crack density, that 20%, is just a good general guideline or rule of thumb. And when looking at crack width, so I mentioned earlier about, when do you start crack sealing? Well, as soon as you have cracks open up, time to start thinking about it. So anything hairline to about 1/8 of an inch up to 1.5 inches wide is a candidate for crack sealing. If the crack density is less than 20%, now we're going to say route and seal that. So again, cracks 1/8 of an inch to 1.5 inches. With less than 20% crack density, we're going to say route and seal. If it's a 1/8 of an inch to 1.5 inches wide crack, but has greater than 20% crack density in that pavement, we're not going to recommend routing. We're saying that's appropriate to just do a blow and go application. Anything over 1.5 inches wide is too large of a distress for crack sealant alone to accommodate. So once you get into wide cracks, and there's a good example of that in the picture on the far right here. I can't get my arrow to work. I apologize. But in the image on the far right, you can see an old construction joint that is opened up really wide, and it's a great candidate for mastic. So anything over 1.5 inches wide, that's when we definitely recommend moving from a crack sealant to a sealing mastic. And mastics have aggregates in the binder, so there's additional structure and support in that material to be able to seal up wider distresses, and as you can see in that middle image there. All right, and pavements have gone too far. So crack sealing obviously is not appropriate everywhere. Anywhere you have extensive fatigue cracking, if you have structural failure, if you have base failure or underlying pavement-based issues, other types of way more rehabilitation or reconstruction is going to be necessary. Crack sealing would not be appropriate in those conditions. All right, so we're now moving into our fourth section where we're going to talk about installation best practices. Jason, if you can go ahead and launch our next polling question. So for all of our attendees here, how familiar are you with crack sealing operations, actually going out and doing the work? Are you somebody that's really familiar with crack sealing, intermediate, pretty familiar, or are you a beginner or not very familiar with the actual application process? We'll give a couple more seconds here. Lots of answers are still flowing through. All right, looks like Jason shared those results. Couple people still answering out there. All right, looks like the majority are beginners, are not very familiar. All right, so thank you, Jason. It looks like we're just about done with the answers. Thanks so much. So let's go ahead and take a look. This is going to be very high level. As I mentioned at the very beginning of this presentation, this is a two-part presentation. So in the future, we're going to have another session. Brian Darling, our Western Regional Manager here at Craftco, is going to go through and do a presentation on crack sealing equipment and all of the details of installation best practices. But for the intents of this presentation today, I'm just going to talk at a very high level about the basics. So for those of you beginners out there, this will be really great info. So best practices. These three things are imperative when crack sealing. One, that pavement must be structurally sound. Two, it has to be dry. Conditions must be dry. We don't want any dampness or water down in that crack. And it has to be cleaned out. So these are the three most important things with crack sealing. Clean and dry, structurally sound pavement. So what does that mean? If we're talking a structurally sound pavement, an intact bonding surface, we want no loose raveling or loose aggregate or surface raveling. That's not to say that if there's just loose aggregate on the roadway, that's fine. That can be blown off with an air compressor. But we are looking at all of the types of cracks that were shown in the previous section are all great candidates for crack sealing. So again, good bonding surface, no raveling, and no loose aggregate inside of that crack face. Dry, it has to be dry. If there is moisture present inside or down inside of a crack, it is going to negatively impact the adhesion and the bond of the sealant to the asphalt surface. So it's imperative that it be dried out. If it rains or it's been damp, close to the dew point, wait a few days. Even if it had been a few days since the last rain event, but it might be close to the dew point or still damp outside, we're going to highly recommend that you use a hot air lance to really get down inside of that crack. Even though you might not be able to see moisture with your naked eye, it can and probably likely is still present down in that crack. So it's just a good rule of thumb to use a hot air lance there. Get out any moisture or dampness that might be down in that crack to help improve the adhesion of your sealant. Because ultimately, we want it to stick, right, and do its job and seal that crack. Weather considerations. Ideally, we are looking for moderate to warm temperatures. Now, that's why spring and fall tend to be ideal crack sealing seasons across the United States. In most locations, the spring and fall are those times of year when our temperatures aren't our hottest and aren't the coldest. So spring and fall tend to be ideal crack sealing seasons. Little to no wind is also ideal. If you have increased wind, then you need to worry about keeping the material temperatures accurate, and your temperature of the pavement is important. We're looking for 40 degrees Fahrenheit minimum. So 40 degrees Fahrenheit is that pavement temperature minimum that we are looking for. If it is cooler than that, again, we definitely recommend use of a hot air lance to bring up that pavement temperature, remove any possible moisture that might be in that pavement, and it will help loosen up the old oils and binder in the asphalt and help with that adhesion and bond when you're crack sealing. So crack sealing is one of the few applications that can be done year-round if conditions are appropriate. We just mentioned that spring and fall are ideal. We see that all the time. We see summer crack sealing programs around the United States. Very typical. We see that customarily. I am out here in Phoenix, Arizona, so we do not see that out here in the summertime here when it's 120 degrees outside. But a lot of places in the United States, we know they're crack sealing out in the summer. Excuse me. And in places, we have seen successful winter crack sealing programs. Again, conditions have to be appropriate for a winter crack sealing program, but it can be a good alternative when there's no other construction projects that can be completed at that time of year. If conditions are that it's dry, there's no actual snow accumulation on the ground, excuse me, you can crack seal in the winter, and we have seen some northern states achieve really successful winter crack sealing programs. Again, we're not going to go into all the details today, but if it's dry, the air temperature can be virtually anything. What we're always focused on is that pavement temperature. We know it's cold, so you're definitely going to have to use a hot air lamp in a winter crack sealing operation, increase that pavement temperature and help with that adhesion. And then last, again, of the three main pieces, structurally sound, dry, and clean, has to be cleaned out. Crack sealant is extremely adhesive. It's really sticky. Whatever you put it on, that's what it's going to stick to. So in this top image here, you can see all the dirt and debris down in that crack. If we were to put crack sealant down on that crack, the sealant is not adhering to the asphalt. It's sticking to that dirt in the crack. And after that sealant cures, you'll be able to walk over, bend down, and pull that right out of that asphalt. It's not going to be able to, it's not going to do what we're intending it to do. So it's imperative that cracks be cleaned out. Use of an air compressor is the most common crack cleaning operation. Just get down in there with a compressor, blow it out. You can see the difference in this second image on the bottom. This is nice. It's been blown clean, free of debris. It gives the sealant sound asphalt sidewalls down inside of that crack so it can adhere to it. Very important. And looking at some installation designs, the four images shown here, we're going to start left and move to the right. The image on the left is a blow and go operation. You can see there is just a small crack and has not been routed. So this is a blow and go operation. You're just going to clean this crack out, come in, put some sealant down, excuse me, and put an overband on it. With this operation, we typically see approximately 44 months of sealant service life. Going over to the standard flush reservoir fill, so now in this case you can see in this image that we have routed this crack. So we've run a router on this crack, opened it up, filled it with sealant, and we're doing a flush fill just up to the surface of that pavement. Studies show that in this type of an application, we're getting 70 months of sealant service life. So we're doing better. Now when we get into routing with an overband, this is where we see the greatest performance in terms of the longest sealant service life. So in this third column, this is a shallow reservoir. We see this typically in extremely cold climates. So think Montana type climate, very, very cold, minus 40 C. What we're doing here is doing a very shallow, wide route, filling and putting an overband on that. And we're seeing 92.5 months of sealant service life in this type of an application. And then what is standard in most areas for a route and seal is this last chart here on the far right. Standard route with an overband application, and we see approximately 94.5 months. So that's almost 8 years. So we're seeing great results. So there is definitely a correlation between the type of installation and the performance you're going to get out of it. And this is the next look at some of the other types of crack sealing configurations. Across the top here, here's just a simple flush fill starting at the top left. So we're just going in, blowing a crack out, not routing, probably have a straight tip, putting it down inside of that crack, filling it flush to the pavement. That can be difficult following along meandering and random cracks. The one in the center cap, so here again, no routing. We're just going out, blowing it out. Looks like probably running over it with a wand with a sealing disc on it. And then the image on the far right, a simple Band-Aid again, a blow and go operation, blowing it out, sealing that crack, and it looks like using a squeegee to put an overband nice and tight to that pavement there. On the bottom here, we have reservoir with an overband, and as we looked at on the prior slide, this is the longest or highest performing application technique. So a reservoir with an overband is the longest lasting sealant application type. In the center, we have a recessed reservoir. This is common whenever there's going to be maybe an overlay coming in on that treatment, so they don't want that sealant material up flush with the road or on the roadway surface. Same with the reservoir in flush fill. And then a shallow reservoir with an overband, as I mentioned on the prior slide. That is where we see greatly used more so in extremely cold climates. So just a look there at some of the different application types. So this image here is a route and seal picture, and this is what we want it to look like. This is a very nice looking job. We want to see that overband nice and tight to the pavement. We want that overband not to extend any more than 1 inch beyond each side of that crack. I know we've all been out there on the roads and have seen sometimes overbands 8 inches wide, a foot wide. More isn't always beneficial in crack sealing. It doesn't look good, first of all. It can be sloppy. So nice, tight overband, tight to the pavement, no more than 1 inch on each side of the crack. Here's another look at a great a job as well. They came in and routed out some of the larger cracks. You can see there's some other secondary cracking they did not route because the crack density was too closely spaced, so they did a fabulous job there, and then came in and sealed everything up, whether it was routed or not routed, sealed it all up. Looks really clean, very good job in this image. So let's take a look at the not-to-do pictures. So some of the images we see here, the first one on top, this is an example of sagging. This isn't very extreme. This is not a very bad picture. We've seen much worse. But you can see that sealant is kind of sagging and oozing down into the crack there. It's not flat and flush with the surface of the pavement there. Often what happens is you need to go over and maybe do a second coat of sealant, run over it twice. That operator needs to go back over it. Or you might need to switch and go to a higher viscosity sealant. The second image is down on the bottom, number 2. You can see this puddle of sealant out here. This happens because, again, we know roadways are designed to flush off to the edges of the road. So if you have a sealant that's lower viscosity, it does have a tendency to want to run out to the edges, or if the operator's moving too quickly. We don't want to see this. We want the operator to go back over that with the wand and smooth that out. A couple of reasons. One, tire traffic catching that has a possibility to maybe track that. And 2, if you're in a colder climate where you have snowplows in the winter, snowplow might catch that and rip that up. So that's why it's very important to have a nice, tight overband for your sealant. And then in the third image here in the center, this is just poor workmanship. This is just a sloppy application. You can see there's way too much sealant that's been applied, extremely thick overbands, there's drips everywhere, just very poor workmanship. So you can see the difference in the images of what good looks like and what poor looks like. Whenever you're done opening to traffic, we get asked about how long before you can allow cars to run over the crack treatment. And again, that's always hard to answer straight out. Other variables come into place. What's the temperature? What's the ambient temperature? Is it damp and humid out today? Is it pretty dry? All of those types of things. You know, traffic, if your crack sealing transfers across the pavement, traffic will be on and off of that sealant quickly. If you're sealing longitudinally, a car can potentially be running down that length of that sealant the whole way. So what we recommend is using a DTAC product if you want to open up the treatment area to traffic sooner. It does not cure the sealant any faster. It just acts as a detachifier on the top of that sealant to prevent tire pickup when it runs across it. What we don't recommend is other types of blotting materials like sand, or some people will use like a lime or a slag type and sand on top of it. As you can see in this image here, we have the famous toilet paper that's used as a blotting material. We don't recommend these items. Often they can alter the properties of the actual sealant. They can degrade the flexibility of that material by being embedded in it. So we definitely would recommend using a DTAC product instead of one of these types of materials. So now that we've wrapped that up, let's move into our last section where we're going to talk about crack sealing specifications and testing. So Jason, if you will please do the honors and launch our last polling question. Want to get an idea from the group here. So how familiar are you guys with crack sealing specifications and testing methodologies? You pretty familiar, intermediate, or not very familiar? If you'll take just a quick second and respond, we greatly appreciate your participation and giving us this feedback. Helps us understand what pace we should move at as we move through each section here. All right. Looks like everybody, a couple of answers are still coming in. All right, but it looks like mostly beginners. Okay, all right, very good. Jason, thank you so very much. And everyone, thank you for participating, giving us your input. So we're going to talk about the specifications for sealant. So I always like to start with the factors that crack sealant has to withstand and stand up to. Sealant is subjected to a ton of stresses: seasonal thermal changes, traffic loading, water, rain, oxidation from the sun, abrasion from plows, temperature extremes, right? It's going to be getting beat up all the time. So we need to make sure that our sealant materials are appropriate for the roads they're going to be put on, because they need to be able to withstand the stresses they're going to be exposed to. So one of the very first ones that you always need to take into consideration is climate. It can get extremely hot in certain areas. That's very true here. I'm in Phoenix, Arizona. Pavement temperatures are extremely hot in the summertime. You need a sealant that is going to be able to still maintain its stability and not track and run and become liquefied at extremely high pavement temperatures. In other areas of the country, it's extremely cold, and you need a sealant that's going to be able to maintain a softness and a flexibility in the wintertime and be moving without cracking open. So climate and temperature is very important when selecting a sealant. And the crack sealing spec is ASTM D6690. And I'm not going to go into great detail on all four of the types, but there's type 1, 2, 3, and 4. And they all have different testing and cycles and temperatures, but the main difference distinguishing type 1, 2, 3, and 4 of our crack sealing specs are low temperature. Type 1 is for areas that's up to negative 16 degrees C. Types 2 and 3 for negative 22 or minus 28 C. And type 4 is what we call a low modulus product. These are for extremely cold climate. So you're looking at minus 34, minus 40 C areas. So that's the main differential between the four types of the crack sealing spec, is that low temperature. And the first test that's really important is the bond test. Adhesion is important. Crack sealant has to remain adhered and bonded to the pavement in order to do its job. So what we do is a bond test. You can see from this image what we do is cast some crack sealing material between two concrete blocks, and we run it through a variety of extensions. Sometimes we have to put it in the freezer for quite a few hours. A lot of times the samples are between like negative 20F and 20F. There's different numbers of cycles that we run it through, stretching it out, extending it, 50% up to 200% extension, depending on the test. But the main takeaway is we run it through a lot of tests to make sure it can remain bonded to the pavement surface. So that's a very important test. Because in the field, if you don't have good bond, you get adhesive failure, as you can see here in this image. And the sealant will pull right out of the crack. Another test we perform is the cone penetration test. And what this is testing is the material hardness or its stiffness. As you can see in that image, there's a specimen in a cup, there's a little cone, and it's usually done at like ambient temperature, 77F or 0F, 32F. There's a whole bunch of different temperature range we'll do this in. And what they do is they use a specific weight, like 150 grams is pretty standard, and they kind of push that down in there for about 5 seconds, and they just measure how far that cone penetrates into the material. So again, relating back to climate, you wouldn't want to use a sealant with high penetration in an area with extremely hot temperatures. It's way too soft. It's going to not work in high temperature areas. Nor would you want to use a low penetration sealant in a very cold climate. That material is too stiff. It can crack and become brittle in the winter. But this test it's not a sole determining factor of which climate a sealant should be used in, but it is one of the important measurements for that. Softening point. Now this is looking at high temperature stability. This measures when does a sealant material stop being a solid and now turn into a viscous liquid. So at what point does it melt, basically? When does it go from a solid to a liquid? And what we are measuring this for is to make sure that the material is able to maintain high temperature stability on the pavement while traffic is running over it in the extremely high summer temperatures. Usually a material that is about 176 F is best for a reservoir application, meaning that there's not a lot of material on the pavement surface. It's not as open to tire traffic. If you are doing an overband application, you know that that overband is going to be exposed to tire traffic. What we always recommend is that the softening point be 25 degrees higher than the pavement's highest temperature in the summer. That way you can ensure that that sealant will maintain high temperature stability in the summer months. Why is that important? Because of tracking. As you can see in these images, tire pickup is the image here on the left. And on the right, this is an image from here in town in Phoenix. This is an entryway, I believe, into a school. So you can see what happens when the incorrect material is selected. Tire traffic picks it up and it tracks it along the road and causes some messy issues. So that's why that softening point and high temperature stability is so important. Now on the opposite end of the spectrum, let's look at low temperature stability. This is also extremely important. A sealant being able to maintain its flexibility so it doesn't crack open in the winter. So we do a flex test called a bend or a fracture test. So we take a sample of material and we bend it around a mandrel at a specific temperature, and we see if it cracks or not. That's the basic formulation for how this test is approached. So we're checking for flexibility ultimately to prevent this, as you're seeing, cracking. We want that material to be able to perform season after season after season for you without cracking open. Another thing we're going to talk about is elasticity. And the way this was explained to me once made complete sense, and so I completely plagiarized it, and it's how I explain it now. When we're talking resilience or elasticity, it's the difference between a rubber band or like chewing gum or silly putty, right? We know with a rubber band, if you stretch it and pull it apart and you let it go, it snaps back to its original shape. It's highly elastic, highly resilient. Silly putty or a bubble gum or a chewing gum, we know that if you pull it, it just kind of oozes out and stays there. It doesn't try to pull back to its original shape. So that's a low resilience material. So why are we measuring resilience in materials? It's important because high resilience sealants are able to prevent rocks and debris penetrating down into the sealant because they're always pushing back up and they help keep debris out. But at the same time, as you increase elasticity or resilience, you lower the adhesive properties of that sealant. If you think about sealant being inside of a crack, if it's trying to pull back into itself all the time, it's always trying to pull away from the surface of the crack. But elasticity, depending on the type of pavement you have, is an important factor. Viscosity. So we'll talk about viscosity, and I always talk about that in terms of it's a material's response to flow. So water, very low viscosity, right? You can see in the image, turn a cup of water over, it's going to flow out very easily. High viscosity materials like honey or molasses are going to pour out and flow very slowly. So we're always measuring the viscosity of our sealant. And the reason we measure that, and it's important, is as you can see in the image on the left here, if you have a low viscosity material, it can sink and flow down into the crack too far. As you see on the image on the right, which we saw earlier, it can run down or puddle off on the edges. So in those situations, you might want a higher viscosity sealant. If you're working in, we have a lot of canals here in Arizona, so those are high sloped areas, right? If you have something that's a sloped area, you're going to want a high viscosity sealant. Now, if you have very small cracks that aren't very wide, you're going to want a lower viscosity sealant so it can flow down into those cracks so you can get enough material in there to be able to seal those cracks up. So in a nutshell, coming up to start wrapping up here, the main takeaway is leading into that there are a lot of variables that need to be looked at when selecting a sealant. We've gone through a lot of them today. Pavement types, the cracking type, it's the crack spacing, density, what are future plans? Are you going to do another surface treatment in the future? What traffic looks like? Is it a pedestrian area, traffic volume, speeds, the width of the crack, the type of materials or equipment that you might have, the cleaning method, how you're going to install the crack sealant. All of these things come into play. And in a nutshell, there are lots of types of sealants, and not all sealants are the same. Because there are so many variables and conditions, a lot of different sealants are manufactured to be the right sealant for the right road at the right time. So I absolutely encourage you, if you're not sure or if you're new and just looking at starting a crack sealing program, or perhaps you are crack sealing and you don't know if you're using the best material or you don't know if it's performing well, I absolutely encourage you, reach out to the manufacturer in your area, talk to your rep, have a discussion, go through the data sheets, look at the tests, understand that sealant and the different sealants and what is going to be the best product for you and give you the highest level of performance to last years and years for you. So some final thoughts, good candidates, again, about preservation, new pavements or rehabilitated pavements. Studies indicate that even good, fair, and in some cases poor condition pavements benefit from crack sealing. Percent of cracking should be taken into consideration when you're looking at a pavement section. Little to no secondary cracking can be important whether you're routing or not. We want to make sure there's no raveling at the crack face, so we're talking about that. Intact and sound, structurally sound pavement, good base support, no underlying issues, and limited to no structural deterioration. Some links are here on this next slide to send you to some resources that can be very helpful for you for additional information. There is a sealant selection guide on Craftco's website that's listed there. The FHWA has a great series of checklists for different pavement preservation techniques. They have one for crack sealing. That's available there for you. PPRA has their roadresource.org website, which has been highly touted recently. It's a fantastic resource. If you haven't visited yet, it has all types of different pavement preservation treatments, tons of information, all kinds of great data in there, calculators to help you out and figure out what treatments you should be doing when and where, how to balance your money out, lots of great resources there. And NCPP also has that pavementpreservation.org website with a ton of great data. So there's a lot of resources out there for you. And in closing, I'm just going to turn it back over to Jason now to see if we want to move into our Q&A part of the presentation. Thank you, everyone.
Great job, Brandy. Well, let's run through some of the questions, and the first one we have is from Marvin Williams. What is a non-working movement crack?
So a non-working crack is what is considered a low-moving crack. That would be defined as anything that's moved less than 1/8 of an inch a year. We know reasonably you're not out there with a ruler, again, measuring them. So a good rule of thumb to understand, if you're looking at a low-moving crack, it's typically a longitudinal crack or a fatigued crack. The more cracking that is present, the higher the crack density, the lower the movement. So fatigue cracks, high-density block cracking, and longitudinal cracks are your lower moving cracks typically. I hope that answered that question.
The next question is from Lynn Evans. How long after crack seal pre-treatment can we apply chip seals?
That is a fantastic question, and we get asked this a lot, and unfortunately I don't have a straight answer for you. We have seen folks that go out and they crack seal and put a chip seal down the next day. Some places wait a few weeks. Some say wait a few months. I'm definitely not an expert on chip seals and being able to make that determination. But in terms of what we see happen in the field, we see a wide variance of how long people wait between a crack treatment and applying a surface treatment. But oftentimes we do see it pretty close together. But of course, like always, variables always come into play.
How about AC overlays? How long after crack seal penetrates?
I'm sorry, Jason, did you say it for an overlay?
Yeah. You see it about the same concept?
Yeah, that would be the same concept. And again, it depends on if you're doing a recessed fill. So if you're going to route and do a recessed fill, you're not going to have that sealant be open to the traffic or be touching that hot asphalt when they're coming in and rolling that. So we definitely want to recommend like a recessed or a flush fill type application. Your tacking material is going to be very important. There's some good studies. We can follow up after this call. There's some good white papers on crack sealing prior to an overlay and the prevention of bump formation and such. So we'll follow up, and Jason, I'll work with you to get that data out.
Sounds good. Great answer. Another question we got from Lynn Evans again. Which is more effective, overband seals or flush fill seals? Did you hear that, Brandy? Hello? Like we lost connection here.
Hey, Jason, this is Brian Darling. I'll go ahead and answer that question. The two different types of treatments kind of have two different places in what you're doing. The reservoir or flush fill, as Brandy had mentioned, would use a treatment that you would use if you're doing an overlay or surface treatment over it right away. That would be the type of treatment you want to use there. The treatment with an overband generally is used if you're going to leave it open to traffic with no surface treatment on it for a while, maybe up to 6 to 8 months, maybe even a whole year before you come back and do a surface treatment. That allows that overband to help seal and reinforce the edges of the asphalt. And then if you are going to do a surface treatment, say the next season, the tire traffic is going to smooth that out, so then you don't see the issues with any kind of bumping or bleed through as much when you do your surface treatment.
Thanks, Brian.
Yeah, thank you. Sorry, I got disconnected, so I just dialed back on. Thank you for jumping in, Brian. I appreciate it.
Well, welcome back. Got another question from Zachary Stewart. When should we route? I hear you don't route cracks. Why wouldn't you want a fresh surface for the material to adhere to?
So can you read that to me one more time, Jason?
Sure. When should you route? I hear you don't route large cracks. Why wouldn't you want a fresh surface for the material to adhere to?
Oh, gotcha. Thank you for rereading that. So routing, a good rule of thumb is anytime you have if you have a high moving crack, so anywhere you have transverse cracks that are spaced, 10, 50 feet apart, you're definitely going to want to route those. We anticipate they're going to be high moving cracks. Crack width is definitely an important factor. If it's very wide, you don't want to go in and open it up even more unless you're moving to a mastic material, at which point you wouldn't need to route. But if you have crack density of 20% or below, so again, looking at a section of pavement, you're assessing how much linear cracking do I have based on the square footage in the section of pavement. If it's less than 20%, we're going to recommend routing and then sealing those cracks.
Hey, Jason, Brian again, let me jump in and go a little bit farther with this. On a wide crack, if you look at that crack and the sidewalls are very deteriorated or oxidized, you might want to run a router down through there and just take off no more than 1/8 of an inch, maybe just off the face of that wide crack to get you back to good sound asphalt for the sealant to adhere to. But generally, we don't see a lot of that being done, but it is a practice that we should look at in a very deteriorated or crack that has a lot of deterioration inside that crack.
Thanks, Brian. Next question, I believe, Brandon, you covered, but it's which month or season of the year is the optimum time in crack sealing or filling?
Yeah, so typically we see when temperatures are moderate in your area. So most places in the U.S. are going to be spring and fall time. Again, it's when your temperatures aren't the highest they'll be all year, and they're not the coldest they will be all year. That's when it's ideal. But again, one of the beauties of crack treatments are that if conditions are appropriate, you can perform crack sealing in all 4 seasons if conditions are appropriate.
Great. Should you use backer rod with cracks?
You can use backer rod. We don't see it very often in asphalt unless you're doing routing of joints. So if you're pre-cutting joints in and using a backer rod and then sealing on a new pavement. Other times we see backer rod is when you're actually doing joint sealing in concrete. So if you're using a hot pour or a crack sealing material and sealing joints in concrete, then you would absolutely use a backer rod in those applications. But we don't see it typically in random cracking in asphalt pavement.
The next question, what is the difference in life cycle cost comparing routing versus sealing cracks versus blow and glow?
That's a great question. We do have some studies, and again, in just the essence of time, Jason, I'm going to get some data over to you that we can get out to the folks we'll follow up with who asked that question. But there are cost-benefit ratio comparisons in terms of cost effectiveness and life treatment, and how much money are you putting into the treatment versus how much are you going to get out of it. So we do have that data. We'll make sure we provide that.
Thanks, Brandy. Next question. How do you test the crack to determine if it's dry enough to seal?
I don't know if people are actually testing it. I would just say it's just understanding, did it rain a couple of days prior? Are you close to the dew point on the day you're going out and going to be doing your work? Is it humid? Can you visibly see moisture down in the crack? If any of those conditions apply, I would definitely recommend just have a hot air lance out there with your crew. It's very, very fast operation. Run that hot air lance down along that crack out in front of your truck, out in front of your crew. Help remove any potential moisture that might be present down in that crack.
One thing they should also look for as they start crack sealing, if they're unsure, if they start to see a lot of bubbling of the sealant material down in the crack, that's always a good sign that there is moisture down in that crack. And at that point, they should probably stop crack sealing or start using a lance to dry out the crack.
Okay, we got another question. Backer rods versus reservoir life in months. Is there a difference?
I don't know if I have seen any studies with comparing a backer rod comparison. I don't know if you're asking about joint sealing, again, in concrete, or if we're talking crack sealing in asphalt. I would have to go back and look at that study information that I had referenced earlier. Brian, do you know if you have anything that you're aware of off the top of your head?
Yeah, I don't know of anything, a life cycle advantage to using backer rod. Again, backer rod is generally used to make a very specific joint design and not necessarily gives it any better life or takes away from any of the life cycle of it.
Okay.
Yeah, as Brian mentioned, when you're using a backer rod, ultimately it's just in there to really define you already have that joint width, right, cut out. The backer rod is really just aligning what the depth is going to be, so you get the appropriate amount of materials down in there with the depth ratio. And once that material, like when you're using silicone or anything, once it cures, a lot of times that backer rod just falls off and it really doesn't have any additional purpose beyond that. So, but again, we'll get that data that we have on the other treatments and designs out to Jason for everyone to take a look at.
Thanks, Brandy. Next question. How do you test tracking?
I'm not sure. How do you test tracking?
Yeah.
So I don't know if that means, well, you'll see it. You'll see it out there. It's there. You'll see the sealant's tracking, and you can see the black is smooshed. You can see where the tire traffic and abrasion has pushed that sealant material, and it's lifting up and tracking along the road. The test for that's most important for that is that softening point test. If you go to your manufacturer, for instance, if you go to our website or whoever manufacturer you purchase your material from, look at their product data sheets, their installation instructions. They should have charts that have the testing information for each sealant material, and it should have the softening point temperature. And again, that rule of thumb is if you look, LTPP Bind website has temperature data points for around the whole U.S., indicating what is the highest temperature your pavement will be in the summer and what's the coldest it will be in the winter. And what you want with softening point is you always want the softening point of your sealant to be 25 degrees higher than what your pavement temperatures reach in the summertime.
Great, Brandy. The next question, will there be a follow-up presentation up to sealing cracks in concrete? Do we have that on our schedule, Allie?
At this time, we do not have that on the schedule, but it is something that we can consider for later in the year or next year.
Great. All right, this is a long question here. What criteria do they need to decide a treatment, and are we collecting the data with the automatic vehicle?
So I'm sorry, I know that was a long one. Was that asking about the studies, Jason?
Let's start off with the first part of it. What criteria do they need to decide a treatment?
Oh, how to select what treatment you're going to do. I will refer to, again, in essence of time, that's a great conversation. That's a fantastic question. And a lot of different variables come into play. How are you monitoring your infrastructure? What money do you have in the budget? What other treatments are you trying to do? So I would definitely refer to that link that we put up there for the PPRA, the roadresource.org website. They have a great tool on there to help you map out different treatments and the costs and managing your network. That's one resource that exists. I know there's a lot of pavement management software that exists out there that different DOTs utilize to help with making those decisions. So there are resources that are available out there.
And the last part of this question, are we collecting that data? And one of the things you referenced is by an automated device, vehicle.
Oh, so it's in your territory. Do you own the equipment? You're going out and measuring the cracking. Brian, I'm going to throw this over to Brian. I know he's out in the field a lot more, but I believe a lot of places just do visual inspections and such. Do you have any commentary on that, Brian?
Yeah, a lot of it is visual. I mean, some agencies have gone to the automated vehicles to do road assessments and stuff. We don't get too involved in that part of it. Generally, it's after they've done their assessment and, then they start asking about what types of sealants to use and stuff is where we get involved. We do know that some of the tests that are being done on the test pilot or the demo areas and stuff, they'll use the automated collection vehicles to, look at how the road is doing and that kind of thing. But again, we don't get too involved in that part of it.
Jim Martin responded back saying automated vehicles do a great job on providing crack widths, and you can request they sort the cracks to the width dimensions to your desired. Read the rest of it to your range of treatments. Thank you, Tim. Response back from Marvin and Carolyn. They appreciate you responding to the questions, Brandy. Thank you. Dwight Ramos, what is the lifespan of crack sealing treatment?
So the lifespan can vary greatly depending on the application configuration. If you're doing crack sealing material in a blow-and-go operation, not routing, 5 years is kind of the average, up to 7 or 8 years is what we see. If you are routing, we see up to 10 years on average. So the sealant service life is definitely correlated back to the installation or the construction of that project.
And I believe, Brandy, as you mentioned, it's really dependent upon the sealer that you use. Not all sealers are the same.
Correct. So quality sealant and a quality installation are the two variables that are going to get you the greatest performance out of your crack treatment.
Which leads to this, one of our last questions, or is our last question, from Marshall Gonzalez, if I pronounce it right. Are there any field pool tests out there to test the bond after 1 year? And maybe 2 years, and et cetera.
Okay, good question. So on the crack sealing side in asphalt, not so much, it's more of a visual inspection. You can go out and kind of go down and grab it. It's stuck or it's not. If it's not bonded, you can see it. You can reach down and pull it out. It'll what we call roping out, of a pull out of that crack. For joint sealing and concrete, we absolutely do perform a pull test with silicone. Again, for joint sealing, where you go in and you make a cut, and you make a 90-degree vertical pull on that specimen, and you want it to snap off and not rope out to check that it's bonded appropriately. So again, depends on if you're looking at concrete, joint sealing with silicones, or if you're looking at crack sealing and asphalt pavement.
Great. Thank you, Brandy. I'd like to thank Brandy and Brian for their excellent presentation and answering the questions. Much appreciated. For further information on Brandy and Brian, their bios are on the side, on the files. You're welcome to download them and contact them, as well as the presentation for today. You're welcome to download that as well. In addition, we also have, like many things, we have an evaluation at the end. We use this evaluation information for future workshops. If you see things in there that you like or would like more, please comment appropriately, because with your feedback and your input, we'll make these even better in the future. So please take the time, and I'll keep this open for the next 10 minutes. Take your time, go through them, and we really do appreciate your time. But before I go, I do have one last, I need to switch over to, I'll come back to this evaluations after we got one more slide that we want to talk about our future, and I'll let Allie talk about what our next webinar is going to be for next month.
Thanks, Jason. We just wanted to say thank you again to Brandy and Brian and Jason for this webinar. The next webinar in the series is scheduled for June 18th at 2 p.m. Eastern, and it will be hot in place recycling. More information to register, the link is up there on the slide, or you can visit roadresource.org to register today. And we look forward to our next webinar with you guys. Thank you.
Thank you, Allie. I like the last comment. I want to just wish everybody, please stay safe, and then I'll go back to the evaluations. We got about another 4 more minutes. If somebody has any questions, feel free. Chat pod's still open. But if we don't have any further questions, I just want to say thanks everybody again, and we look forward to our next month webinar, and please take the time out and create the evaluations. Much appreciated. And have a wonderful day. Thank you.
And that concludes our conference for today. We thank you for your participation and for using AT&T teleconference service. You may now disconnect.